In this video I'm going to explain how to solve this mixed circuit. As I can see in this circuit I have first a resistance in series, then a parallel, but on one of the branches of the parallel there are again two resistors in series. So it is a mixed circuit and I cannot apply directly any of the formulas of the mixed or the parallel circuit. First I will have to do the equivalent circuit to transform it into a simple circuit, a series or parallel circuit, which I can solve. So how do I simplify this circuit? First, with resistance 2 and 3, since those two resistors are only in series, I can simplify them into resistance A, the first equivalent resistance of this circuit. I cannot use the resistance 1 or resistance 4 since those two are in series or in parallel with, in the case of resistance 1 is in series with a parallel, and in the case of resistance 4 is in parallel with two resistors in series. So it's not, they are again mixed circuit by itself, so I cannot simplify it, but I can simplify resistance 2 and resistance 3. After that I will have again another mixed circuit, because resistance 1 keeps being in series, but resistance A and resistance 4 are in parallel. So I will have to make again another equivalent circuit like this one by solving this parallel. So the first part will be to find the values of resistance A and resistance B. I will start with resistance A. Since resistance A is the equivalent to two resistors in series, I can apply the formulas of series circuit, but only for resistance A and resistance 2 and 3 that form the resistance A. So resistance A will be equal to resistance 2 plus resistance 3, which is 75 plus 125, equal to 200 ohms. And now that I have resistance A, I can find the value of resistance B. In the case of resistance B, it is the equivalent of two resistors in parallel, so I have to apply the formulas for parallel circuit, but for only for resistance B, resistance 4 and resistance A. So 1 divided resistance B is equal to 1 divided resistance 4, which is 1 divided 50, plus 1 divided resistance A, which is 1 divided 200. The result is equal to 5 divided 200. After that, I have, since this is the inverse, I have to do the inverse again by turning this fraction upside down. Instead of 5 divided 200, I have 200 divided by 5. So resistance B will be equal to 200 divided by 5, which is 40 ohms. And with the values of resistance B and resistance 1, I can finally find the total resistance of this circuit. Since this last circuit is in series, I can just apply the formula for series circuit. So total resistance will be equal to resistance 1, which is 140, plus resistance B, 40 ohms, which is, and all of that is equal to 180 ohms. And since I have from the beginning of the exercise the total voltage, which is 9 volts, and now I have just find the total resistance, I can apply the Ohm's law to find total intensity. Total intensity will be equal to total voltage divided by total resistance, which is 9 divided by 180, which is 0.05 amperes. After that I will have to find all the partial voltage and intensities. I'm going to start with intensity 1 and voltage 1, since the resistance 1 is the same in the last equivalent circuit as in the original circuit. So I will already have the value for its intensity. So with intensity 1 and resistance 1, I can apply again Ohm's law for its voltage. Voltage 1 will be equal to intensity 1 multiplied by resistance 1, which is 0.05, multiplied by 140, and that's equal to 7 volts. I cannot do the same for resistance 2, 3 and 4, since those resistance are not present in do not appear in the last equivalent circuit. So I will have to find first the magnitudes of resistance V, in this case the voltage V. I will find voltage V because since resistance V is the equivalent to two resistors in parallel, I can see here the formula. Once I have voltage V, I will have voltage 4 and voltage A. So I apply the Ohm's law again to find that voltage V is equal to intensity V multiplied by resistance V, which is 0.05 multiplied by 40, and that's equal to 2 volts. Once I have voltage V, and now I will have voltage 4 and voltage A, so I can apply the Ohm's law to find intensity 4 and intensity A. Intensity 4 will be equal to voltage 4 divided by resistance 4, which will be 2 divided 50, and that's equal to 0.04. And intensity A is equal to voltage A divided by resistance A, 2 divided by 200, which is 0.01. If I want to make sure that I didn't make any mistakes, I can try to sum up intensity 4 plus intensity A, as I have here. Intensity 4 plus intensity A should be equal to intensity B. 0.04 plus 0.01 equal to 0.05 is the same as the intensity B, so it is all correct. And with I already have the information for voltage 4 and intensity 4. I'm just missing the information for voltage 2 and 3 and intensity 2 and 3. But I have already found intensity A, and since A is the equivalent to two resistors in series, I have the formula here. Intensity A will be equal to intensity 2 and intensity 3. So I already have intensity 2 and 3, and with that I just have to apply the Ohm's law to find voltage 2 and voltage 3. Voltage 2 should be equal to intensity 2 multiplied by resistance 2, which is 0.01 multiplied by 75 equal to 0.75. And voltage 3 is equal to intensity 3 multiplied by resistance 3, 0.01 multiplied by 125, which is 1.25 volts. To make sure that I have made it correctly, I should try to sum up voltage 2 plus voltage 3, and it should be equal to voltage A, as I have here. So 0.75 plus 1.25 equal to 2 volts, and voltage A was 2 volts, so it is all correct. So that will be the end of this exercise.